Hi everyone, thank you very much for having me here. Special thanks to Chris for the invite. I'm very happy to be here and give you a bit of a talk about water quality and with a specific focus on the River Isle. So what I'm going to do is talk you through who I am. I'm going to give a little bit of an overview of Wessex Water. I'm going to talk about my role and the role of my team and what we do. And then I'm going to talk about some of the environmental investigations that we do as part of my team. Then I'm going to talk you through eutrophication and sources of phosphate. Then we're going to look at what's going on the River Isle and talk about some of the Somerset specific investigations that we've been doing in the area and the partnership working that we've been doing. Then I'll finally conclude with a few concluding remarks. So who am I? I'm John Bagnall. I started off a long time ago. I did an undergrad in marine biology, which admittedly has nothing to do with rivers, but in many ways, this is how a lot of environmental scientists start. They start in ecological fields or marine biology. You'll be surprised the amount of marine biologists that we have in Wessex Water. Then I did a master's in aquatic resource management at King's College London. Then I did my PhD at Cranfield University, which is in water and wastewater engineering. Then shortly after that, I did a postdoc at Bath University. Then I was an environmental scientist for a bit with Atkins. And I've also had roles as a water quality modeller. That means that I have been doing some modelling of the catchment to look at what the impact assets have on the environment. I was a principal environmental scientist. I'm now a technical delivery manager, which doesn't really sound that much, and I think I prefer being a principal environmental scientist. It's just got more clout, really, doesn't it? And here's a picture of me doing some monitoring only a couple of weeks ago. So I still go out in the field. I still collect data like you guys do to test what the impact of our assets have upon the environment. So managing rivers and streams. Who's responsible for doing this? I suppose the Environment Agency are. They're our regulator, so they're responsible for ensuring that our assets are don't impact the environment too much. Wildlife and Rivers Trust are also deeply involved and are key stakeholders of rivers and streams, as well as local district and borough councils. Community and local groups and local flood groups, people like yourselves, internal drainage boards as well. Riparian landowners, also key stakeholders in the management of rivers and streams. What about water companies? Believe it or not, we are. So I just want to give a bit of an overview of Wessex Water and what we do. It's almost like a water company 101. Don't worry, we'll get through it quickly. But Wessex Water is, and if I can work out to do the clicker. Oh yeah, here we go. Wessex Water is one of 10 water and sewerage companies. We give ourselves this horrible acronym, WASACs. And I don't expect anyone to remember that or ever use it. But we're one of 10, based down here, delivering to customers wholesome water, and also dealing with boo and wee as well afterwards. So Wessex Water, we have our waste services. We serve 2.9 million customers, and we supply 1.4 million customers with clean and wholesome water. And this map here shows sort of how this is distributed. So we've got this sort of lighter green area here, where we have both water supply and sewerage services, and we provide water and we also provide sewerage services in these areas. These darker green areas, this is where we do sewerage services only. So in Bristol, where I live, this area, the water supply comes from Bristol Water, but Wessex Water provides the sewerage services. And interestingly, the water supply for Wessex Water is quite unique amongst the water companies in that 74% of the water that we supply to the Wessex Water region is from groundwater. We are blessed in that we've got huge chalk aquifers, which we drill down into and use to supply water to all the customers in our region. And only 26% comes from surface waters, either from reservoirs and from rivers. So this is a bit of a schematic of the urban water cycle. So I just want to talk you through what we do and how Wessex Water are involved with this. We abstract water from aquifers, we then treat it, we store it, we distribute it to homes and to businesses. Then we collect all the wastewater, we treat it at water recycling centres, and then we return it to the environment in a treated form. We have a lot of governing bodies. Wessex Water is a heavily regulated business. Just to name a few, so DEFRA up here, they set the policy, environmental policy for water and sewerage. Environment Agency is our environmental regulator that tells us what we need to do at our individual sewage treatment, water recycling centres, I should say. Natural England provide advice on the environment, and particularly environmental designated areas like sites of scientific special interest and special areas of conservation. We are also are involved with the Customer Council for Water, who are linked with Ofwat, who ensure that we keep our bills as low as possible. The Drinking Water Inspectorate are responsible for ensuring that the water that comes out of your tap is clean and wholesome. And interestingly, the European Commission is still up here because a lot of the environmental legislation that we work to was set whilst we were still part of Europe, and these environmental regulations are still very much part of set the requirements for what Wessex Water and other water companies need to do to ensure that we are minimising the impacts that we have on the environment. However, things are probably going to change very soon. I don't know if anyone has heard of the Independent Water Commission, which reported last year, sort of the Cunliffe Review, which happened in 2024 and reported last year, in 2025, pardon me. And then the government, based upon this review, have produced a white paper recently this year. And they have identified that we currently have a fragmented system with lots of different regulators, making it very difficult, with lots of contradicting and overlapping plans, lots of short-term focus on things. And now the government would like us to, the government will produce a new integrated regulator for England to provide a new unified framework. So the hope is things are going to get a lot clearer and easier, and rather than millions of regulators, there will be just one now, which will certainly make my life easier. So in terms of governance, we're heavily governed and regulated, as I mentioned. We have a lot of legislation that we need to follow, going back to 1991 with the Water Industry Act. We also have lots of European directives, which include the Urban Wastewater Treatment Directive that requires water recycling centres over a certain size to have permits for phosphorus and for nitrates. The Drinking Water Directive, Water Framework Directive, and lots and lots of stuff that we need to comply with. We're still operating under EU regulations post-Brexit. However, this may change in the future, depending upon sort of the politics of whoever's in power. So now this is going to be a fun one to try and explain how the water industry is governed and how we're funded. We're funded on a 5-year asset management period cycle, which we call AMPs. And each AMP, at the beginning, we're given a big list of things to do by our regulators. And then towards the next AMP, then we get another big list, and we have to deliver all the things that that our regulators want us to do in that 5-year period. We're currently in AMP 8, which goes from 2025 to 2030, and it's kind of estimated in England and Wales the business plan is going to cost £104 billion to deliver all the things that we need to deliver in AMP 8. And I stole this from Ofwat. This is how that 104 billion is going to be split up. So some of it is going to be on combating nutrient pollution like phosphates. Some of it will be used to reduce the harm from storm overflows. Some of it's to do with water supply. So there's a big list of things that we need to deliver in these 5-year blocks. And this big list that I mentioned, it's called the Water Industry National Environment Programme. It's very catchy, I know. So we have a duty to protect and enhance our environment. And in my team, the list is thousands of different things. And often they're things to do with our assets, like this water recycling centre needs a permit for phosphorus at 1 milligram per litre. That storm overflow needs to increase its capacity by X amount. But when the Environment Agency and Natural England don't know what to do, then they get us to investigate. And they ask us to go and find out what are the causes of an issue and to report back. And then often the things that we find in one 5-year period are then implemented and passed forward to the next period and turned into actions. And so now I just want to talk about sort of water supply and just give a quick overview of what we do and what Wessex Water are doing in terms of extraction. So extract water from the environment, deliver it to your taps, and as I mentioned, we are serving 1.4 million people and 44,000 businesses per day, and it's a huge amount of water. It's 282 million litres of water per day. And if I move on to the next one, which is related to our sewerage services, we serve 2.9 million people, and we are dealing with 472 million litres of wastewater per day. What I wanted to sort of mention is the different types of wastewater that we treat. There is domestic wastewater, which includes human waste and other household inputs. So anything from washing machines, showers, sinks, things like that. So it includes not just human waste, but anything that you take as a medicine, anything that you wash yourself with, and the metabolites from those end up down the toilet and may end up in the river. We also deal with trade and industrial effluents. These tend to be a lot stronger and would have a higher impact on the environment if they weren't treated. And these come from places like car washes and laundrettes, metal electroplating, etc. So there's a variety of different effluents that we treat, and they all go to our water recycling centres and then ultimately release back to the environment. So this slide is about our sewage network that we have. So under our feet, we have a network of pipes which convey sewage from individual households and businesses to our water recycling centres. Mainly they flow by gravity, and this sort of picture here shows a manhole with several sewers intersecting, and then that will then go onto another pipe that goes onto a water recycling centre. Sometimes, however, we need to defy gravity and get the sewage up a hill, so we use sewage pumping stations to help us and give it a bit of a boost. And then ultimately, they go to sewage treatment works. So in terms of sewage treatment works, I'm just going to give you a bit of a 101 on what they do and how we treat sewage. It's an interesting and elegant process. Initially, the sewage comes in and there is some preliminary treatment, and this is grit. This removes grit and large solids. We pass the sewage through a screen, and then it goes on to a physical process, which is the primary settlement. And this involves settlement of large solids. Then this flows into a secondary biological process where we utilise microorganisms to break down sewage. And this helps to remove some nutrients, carbon and nitrogen. Then we could pass on to a tertiary phase depending upon the environmental needs and depending on what the Environment Agency requires us to do. And that could involve UV disinfectant, which might be necessary if there's a bathing water downstream, or if we're discharging to areas where there are shell fisheries and places like that. Additionally, there could be quaternary processes where we're required to remove micropollutants and things like metals. And then eventually, it's discharged to the environment. These processes build up a lot of sludge. Sludge come directly from human waste, but also the bacteria and the microorganisms that are doing the treatment proliferate, build in mass, and we collect that and treat it, and it can be returned to land as biosolids and is often used by farmers as a source of nutrients. Just wanted to sort of mention here at this point, particularly in relation to phosphorus and phosphate, at this point in the process here, we would dose in coagulants to remove phosphate and to reduce the overall concentration of phosphate coming out of sewage treatment work. If we wanted to get an effluent quality of around 2 milligrams per litre, that's where we would place some dosing. If we wanted to improve the effluent quality even more, we would add a second dosing point just between these points, and there we could get down to maybe 1 milligram per litre. If we wanted to go lower than that, then we have to use some tertiary treatment that would give us additional removal, and we could get down to around about 2.5 milligrams per litre. So there you go. That's your water industry, Wessex Water 101 done. And I'm going to get on to my role within Wessex Water and what the environmental investigations team do. So Ruth Jefferson is our chief executive. And I'm not going to mention all of these guys. They do lots of other things to do with finance and engineering and things. I'm a scientist. I work in the Environment, Custom and Compliance Directorate and report to Ruth Barden and Chris Tattersall. Chris Tattersall is the head of environmental investigations, and as I mentioned, our regulators require us to go and perform environmental investigations, and this is done within this team here. So who are environmental investigations? We are a team of 32 environmental scientists, and we cover a lot of different disciplines. This is me here in water quality, but we also do investigations into hydrology, hydroecology, because we're looking at the impact of our abstractions upon the biodiversity in rivers and the impacts that they could have. We also look at hydrogeology, because we abstract a lot of water from the ground. We're also looking at biodiversity as well, and we're interested in nature-based solutions and how we can use nature to help treat the effluent and the impacts that we have on the environment. So we primarily deliver WINEP investigations, and we support them to make decisions based on sound science. But we also perform other functions as well. We do a lot of monitoring, legacy monitoring. We provide monitoring advice. And we also do a fair amount of stakeholder liaison and community engagement and that sort of thing. So what we do, as I mentioned before with this AMP, the asset management periods, what tends to happen is a risk is identified in a previous AMP. Then we would investigate, and then what recommendations are then implemented in the following AMP period. And what we tend to do is we go out and monitor. We look at the impacts and assess them against water quality targets in the river. And then we try and identify solutions of what the most cost-effective, environmentally beneficial way of dealing with our impact on the environment. And sort of a model of how we would do this is we're asked by our regulators to look into a problem. We would scope it up. We would do a desk study and set out a monitoring plan. We'd do some monitoring. We'd analyse the data, come up with, interpret the data, make recommendations, and then report. And then we do it all over again, each AMP period. So some of the reasons that we might do our investigations are due to various pieces of legislation. A key one here is the Water Framework Directive, but we might also do investigations if we're impacting shellfish waters, bathing waters, or areas of scientific special interest and special areas of conservation that are protected under Habitats Directive and other legislation like that. So now I'm going to talk about eutrophication. And sort of some of the sources of it, and then I'll move into some of the investigations that we're doing. So eutrophication is a big issue. It's predominantly driven by high nitrogen and phosphorus. Phosphorus is a key one here because it tends to be the limiting nutrient. It's much easier to control phosphorus than it is nitrate. So in UK rivers, the Environment Agency focus on reducing phosphorus levels to to improve the biodiversity of rivers and the environment. So what tends to happen is these nutrients here can fuel eutrophication. So we get excessive loads of phosphorus can enter the rivers from sources like the water recycling centres. That causes aquatic plants to grow and proliferate, and particularly algae. Algal blooms can prevent sunlight from reaching other plants, and this will cause a drop in the diversity in the environment. Then it can get even worse. You get this proliferation of algae, which will then die off in the bottom as they decompose. This has an oxygen demand, and there is less oxygen in the environment for fish and invertebrates to live. And then ultimately, you can end up with a collapsed ecosystem. The oxygen levels can become so low that plants and animals cannot survive. So what is phosphorus? I'm going to focus on phosphorus because it is a key driver for the work that I do, and I know it's one of the key determinants that you guys have been monitoring. So phosphorus is a fundamental nutrient. We all need it. We require it for life. It's important in our growth and maintenance of our bodies, and is used for the repair of living organisms. It is a key element in the production of genetic building blocks like DNA and RNA. There are various types of phosphorus that can be monitored as well. We monitor all three here. The type that you guys, that Green Ilminster does is orthophosphate, or phosphate for short. And this is what it looks like. It has a phosphate element and surrounded by four oxygen atoms. And phosphate is the amount of, orthophosphate is the amount of phosphate in an unfiltered sample. Another type is soluble reactive phosphate, which is effectively the same as phosphate, but we filter it through a 0.45 micron filter. This is to remove particulates and phosphates absorbed to sort of fine particulate matter. And if we remove that, that tells us what the concentration of phosphate is in purely the dissolved phase alone. However, there is lots of other types of phosphorus as well. So what we also measure is total phosphorus. And because not all phosphorus is in the form of phosphate, it can be bound up in organic molecules. So this this R represents any sort of carbon chain that you might see. So measuring total phosphorus will tell us not only what's in the dissolved phase, but what's in these particulate bits as well. So it will give us sort of a nice overview of all of the phosphorus in the environment. So, eutrophication. These are some pictures that me and my team have taken, and it shows sort of some really sad parts of Somerset. This is on the Somerset Levels and Moors, and you can see this reed here has loads of filamentous algae, and this reed here has excessive duckweed. And the same thing is happening in both these locations. This excessive growth of the algae and the duckweed, it has sort of shut out light from all the other plants living below. Excess growth sinks to the bottom, causes low dissolved oxygen, and very little can live in these types of environments. So understanding the sources of phosphorus and phosphate and doing something about it is very important. So where does phosphorus come from? And there are lots of different sources. A key one is continuous discharges from treated wastewater. So that's the stuff that we discharge from our water recycling centres. It also key sources from agricultural and urban runoff. Also from manure and slurry applications to land. Locally important is feces from farm animals, rodents, pets and wildlife. Also discharges from septic tanks. Sometimes if septic tanks are not managed correctly, they can overflow and spill into the environment, and then you can have a local stream that is impacted by a septic tank. We also, increasingly important are highways and surface water drains, particularly when you combine them with misconnections. Misconnections are when foul drainage from properties or businesses is incorrectly plumbed into the wrong pipe. Sometimes, and this happens fairly regularly, with new developments and extensions. Occasionally, the waste will be plumbed into a surface water drain rather than the sewage system, which then bypasses it directly into the environment. And also, finally, intermittent discharges from storm overflows that also bypasses the water recycling centres and sends sewage directly into rivers. And so these are some of the key sources of phosphorus. Another key driver for the investigations that I do are related to these special areas here. So I've denoted in pink on this map the Somerset Levels and Moors Ramsar site in Somerset. It's the largest area of lowland wet grassland. It's about 70,000 hectares, and it is internationally important for birds and insects, and for some really rare plants as well. Unfortunately, it's being massively impacted by sort of various causes. A key one is excessive phosphorus, often which is and the concentrations often exceed the target. CSMG's Common Standards Monitoring Guidance, and these are targets set by Natural England of 0.05 milligrams per litre, which is very, very low and quite challenging to achieve, but the concentrations are much, much higher than that. Also exacerbating this is summer water management and lack of water, which increases the impact of the nutrients on these Somerset Levels and Moors. And we're here on the Isle, so your closest one would be Westmoor, which is fed directly from the waters from the River Isle. Also exacerbating this is legacy phosphorus in the sediments, which continues to release, delaying any ecological recovery that we might see. So now we're going to move on to the Isle. I'm sorry about that. I wanted to give you a little bit of a one-on-one on water companies and a little bit of bring you up to speed on some important environmental science. But now we're going to move on to the Isle and what's happening in your backyard. So this map here is of the Parrett System catchment. The Parrett does extend beyond there, but I stole this from a report, so to save myself a little bit of time. The maps do get better, I do promise you. But I just wanted to sort of illustrate some of the impacts that you have on the River Isle. So we have 15 Wessex Water's water recycling centres. There are, in addition to this, another 277 other permitted discharges. So these could be things like septic tanks or private sewage treatment works. There's also two key abstractions that we have in the area. For water supply, which is fundamentally important, but it does have an impact in terms of reducing the amount of dilution available in the environment. There are also other abstractors as well for agriculture, private supply, production of energy, and other industrial services as well. So I just want to give you a bit of a snapshot of what the Water Framework Directive assessment is for the River Isle. And I warn you, it's a bit gloomy. Ammonia is classified as high, which is great. Dissolved oxygen, there is one location over here which is reported to have poor status for oxygen. So that means that sometimes the oxygen concentrations can be quite low, and often that is exacerbated by high levels of nutrients as well. But also there's other classifications for fish. There's not a lot going there. The Environment Agency don't always measure fish, but there's sort of one location where it's poor, but there's another where it's really high. We have sort of invertebrates, which are high and good, which is great news. There's the macrophytes and phytobenthos are all sort of in the moderate range, and then the overall ecology is sort of rated as moderate and poor. And in terms of phosphate, there is one location which is good, which is upstream of Chard. And I know this sounds incredibly depressing, but what I want to tell you guys though is these ratings were done back in 2022. So a lot of time has passed, and there's a lot to be optimistic about on the River Isle. So when we see new Water Framework Directive assessments from the Environment Agency, I firmly believe that things are going to get a lot better, particularly in light of all the work that some of the work that Wessex Water has done, and some of the partnership work that has been done across Somerset. So this kind of relates to some of the causes of why the statuses for some of the ecology and chemical elements in the WFD have been rated as sort of moderate and poor. It's a heavily agricultural area, which is denoted by sort of green. There's some urban built-up areas over here, and a little bit of sort of forested area here too. This slide here is hard to understand. I apologise, but sort of the darker the blue, this shows where more phosphorus is likely to be coming from farming and agricultural sources. And you can see there's some hot spots over here and hot spots over there as well. So this is from some psychic modelling that was produced by the Environment Agency. It's quite old now, and this is being updated very shortly, actually. In the next sort of 12 months, the Environment Agency should be producing some more data to show how things have changed. So sort of some of the key causes for elevated phosphorus will be due to extensive agriculture and the water recycling centres that Wessex Water operates. This is, if I zoom in, this is some modelling that the Environment Agency does. I mentioned before in my past life, I did lots of water quality modelling. So I would have been working on stuff like this, where I was modelling the impact of our assets and other sectors on the environment. And this is what the Environment Agency have modelled and what their assessment of the River Isle is. If we just go back, this is sort of based at this little point here, and we think that a good proportion of the phosphorus is coming from sort of livestock and arable sources, and this is kind of as of now. So it's beyond really that that original assessment that the Environment Agency did back in 2022. This is slightly further in the future and takes into account some of the work that Wessex Water have been doing. So I just wanted to give you a bit of a rundown of what our permits for phosphorus at the water recycling centres that we have on the River Isle. So currently, there are 3 water recycling centres that have phosphorus permits. So we have Ilminster, which is permitted to 1 milligram per litre. And we stretch that as much. It has a stretch permit of 0.8, so that means we try and really stretch the asset, sweat it as much as possible to get additional removal from it, and we can get down to 0.8 milligrams per litre at that site. There's also Broadway as well over here, which has a permit of 0.5 milligrams per litre, and also Chard over here, which also has a permit of 0.5 milligrams per litre. I'd be very happy to report, though, that things are going to, there's going to be additional phosphorus removal at our water recycling centres, and by the end of the AMP that we're in, the asset management period, and by 2030, there is going to be 5 water recycling centres with phosphorus permits. And you can see Ilminster is, we're tightening that water recycling centre, and it drops from 1 to 0.3. Chard, it now goes down to 0.3 milligrams per litre. We introduce permits at Fivehead and at Coombe St Nicholas of 1.5. And Broadway is going to stay the same at 5 milligrams per litre. So by 2030, we expect that the phosphorus concentration in the River Isle will decrease even further. And also in terms of storm overflows as well, this map indicates some of the plans that we have to improve some frequently spilling overflows that we have in the area, and a lot of them are clustered in around Ilminster. So there are some that have been fixed already by 2025, which are the sort of darker green, and there are some lighter ones, the lighter greens here around Ilminster and Donyat. They are going to be addressed by 2030, and the amount of spills that come from these storm overflows will decrease significantly. So, and also what I wanted to show is some water quality information that we have for the River Isle, and this is down here right at the bottom, just where the Isle joins the Parrett. And this is Middle Knee, I think. Is that right? Middle Knee? Yeah, good. So, and this is a combination of both Environment Agency data and data from Wessex Water. And it shows sort of this nice cyclical, seasonal sort of change in phosphate concentration between 2010 and 2016 was fairly high. There was a break because the Environment Agency ran out of money, and then there was then COVID hit. So this is why we've got this big gap here. But then when monitoring commenced again back in 2022, initially it was quite high, but then it started to drop again. There was another pause here because this is mainly Wessex Water data. So when we do monitoring, we do for specific investigations. So they tend to be sort of quite short periods of time, so either like 12 months or 24 months. But I've added it to the Environment Agency data, and we can see that we're starting to drop again, and it's a lot less variable, and the concentrations are lower. So the average really is about 0.15 in comparison to pre-2020, when it was more about 3.5. And I imagine by the time we get to 2030, this is going to drop even lower. And that's my real hope from the permits that are being installed at these local water recycling centres. So now I'm going to talk about, I'm scattergunning you with information, I'm afraid, but now I'm going to sort of talk about some of the investigations that we've been doing in the area. And as I mentioned, this is stuff that the Environment Agency in Natural England have asked us to specifically investigate. And one of the key ones, it's kind of in this neck of the woods, is Somerset Levels and Moors seasonal nutrient investigation. This is linked specifically to those Somerset Levels and Moors Ramsar locations, Westmoor and Wetmoor in particular, where we're looking at the seasonal contribution of phosphorus from our assets. We're also doing a nutrient legacy and cycling investigation, which is a partnership project, and we're working closely with Plymouth University, who are helping us out with this. That's to understand sort of the role of sediment in releasing phosphorus as well. And we also want to explore options for how we can sort of flush phosphorus from the system quicker, because I think that the research is telling us that the legacy issue of phosphorus in these environments is a concern. And so we're exploring whether we can sort of push it out quicker by changing the management of these locations through water level management or various cropping of different types of plants, like willow, for example. We're also looking at, we're doing a partnership investigation, looking for opportunities to minimise floating plant dominance. As I mentioned before, duckweed is a particular issue because it smothers other life. So we're wanting to understand what is affecting their productivity and how is this going to change with climate change. Things that the environment's getting getting much more sporadic, so we want to understand how this is going to impact these areas too. And we want to understand whether we can harvest these and whether we can remove phosphorus from these environments by harvesting and taking out of catchment. We're also looking at, which is not necessarily your neck of the woods, admittedly, but we're looking at stuff to do with Durley Reservoir over towards Bridgewater, and also in Currymore, by Stokes and Gregory. We're looking at how we can improve that environment and improve the status that it's been given, and what we can do sort of improve the overall biodiversity of those locations. So, in terms of the seasonal nutrient investigation that we're looking at, so we're assessing, as I mentioned, sort of what our seasonal contribution is to the Somerset Levels and Moors Ramsar. And we're also assessing the feasibility of looking at seasonal permitting at our water recycling centres. We would like to know, is it possible for us to turn up the permitting, turn up the dosing to remove phosphorus during the summer, and what sort of impact that would have on these really special areas that we have in Somerset. The delivery date for this investigation is next year, so watch this space. Hopefully we'll have a lot more information that we can report back by then, but I've got my work cut out between now and then to deliver this investigation with my team. The Somerset Levels and Moors investigation, we are undertaking research into the fate and behaviour of phosphorus. We're exploring how nutrients can be exported from the Somerset Levels and Moors, and we're exploring how we can manage those ditches to reduce the ecological impact of our upstream assets. And the way that we're approaching this investigation is by doing a lot of sample analysis. We're also monitoring our water recycling centres. We're assessing what's going on with these storm overflows, the intermittent discharges as well. And we're also monitoring water quality and the concentration of phosphorus and other nutrients in the environment. And this map here, apologies, it's very hard to see, but this sort of shows some of the key locations that we're looking at. This is West Sedgemoor and Currymore, so this gives an indication of what we're doing. Each of these dots would be a location where we go out on a twice monthly basis to collect, to gather water quality samples that we would then send to our lab and analyse. What we do is we'd go out. I'm sure some of you have got good experience of doing this, going out collecting samples. We also use handheld sensors. This is a handheld sonde that we use to measure pH, turbidity, dissolved oxygen, and conductivity in the rivers. We also, as I mentioned, access our water recycling centre sites and take samples from the final effluent. I have to say our sampling is separate from the compliance monitoring that is done and reported to the Environment Agency. The data that we collect is in addition to that. We utilise that data, but often we go out and collect our own as well. And here's an image of my colleague Lydia with one of these handheld sensors, going out taking some water quality, gathering some water quality data. In this instance, it's in Dorset on the coast, so it's got nothing to do with Somerset, but I thought it was a pretty picture, so I've included it in. Great. So what I want to do is touch upon sort of Somerset, some of the partnership working that we do in Somerset, because I think if you cast your mind back to that source apportionment plot that showed sort of Wessex Water's contribution in relation to other sources, we can't work alone on this problem. We need to be working very closely with other sectors and other partners who work in this environment to try and bring about some effective change to the environment. So we have funded the Somerset Nutrient Technical Advisory Group, or NTAG as we're calling it, to help coordinate the work across all of these different organisations. And these are just some of the organisations that we work with on a day-to-day basis. So we have FWAG, the Farming and Wildlife Advisory Group, Natural England, the Environment Agency. University of Plymouth are doing research into the impact of phosphates on the Somerset Levels and Moors. We work with the Somerset Drainage Board and Somerset Wildlife Trust, as well as the Somerset Catchment Partnership, who hold us all together. So we funded the NTAG. We also provide funding for Plymouth University, and we're also working on with partners on pea reduction trials in Somerset. Things that we can do in the environment to try and draw down some of those legacy phosphates that we're seeing. So just a quick note on NTAG. It's Nutrient Technical Advisory Group, and it's an independent scientific group of national experts that are working within Somerset. And we're looking into the impacts, the sources and impacts of phosphorus on the environment, and particularly as they relate to the Somerset Levels and Moors. We are developing technical support and coordination of existing research. We're trying to give an expert view on what the best available science is in this particular area, and our hope is that we can respond to inquiries from the public and wider stakeholders in relation to nutrient impacts in Somerset. And one of the key pieces of work that we are working to, and we are using the recommendations of, is the phosphorus and water quality in the catchments of Somerset Levels and Moors, which was commissioned by the Somerset Catchment Partnership and ourselves, and we asked Lancaster University to do this research for us, and they came up with these with some key findings. And this was to better understand what the seasonal impacts are, particularly on designated sites. And this is one of the key reasons why Wessex Water is looking into some of these locations. We want to their other advice was develop practical solutions for soil management and to support farmers with that. Develop sustainable manure management approaches. And quantify some of the flows and outflows coming in. So based on this, we're working together with all of these partners, and we are developing some trials. Some trials where we're looking at processing livestock slurries and transporting them out of catchment. Because one of the key findings from this report really was reduce the amount of P going in and do something about the legacy phosphorus that is retained within the environment. And this is fundamental not just for the Somerset Levels and Moors, but pretty much every single river that we're working in. So we want to sort of develop a trial to set up the infrastructure that can deal with excessive amounts of slurry and manure and take them out of catchment. And so that's just sort of an example of some of the partnership working that we need to do. And even though it's not Wessex Water's responsibility to deal with farmers, the amount of phosphorus coming from farmers, but we are there to help and advise and to support where we can. So for the next set of WFD assessments, it should report an improved phosphorus status on the River Isle. And this is down to additional P removal at the water recycling centres and reduced storm overflow operation in the Donyat and Ilminster area. By 2027, I will have delivered the Somerset seasonal nutrient investigation, so we'll have a better understanding of what the impact our assets have upon these special areas. And we will also develop the NTAG more to provide further advice to partners in the area and start to deliver some of the P reduction trials that we're interested in looking at. The concentrations that I showed in terms of a 1 or 2 milligrams per litre, that's in terms of water recycling centre effluent, so what is in that discharge. The levels that are required in the river are much, much lower, but they are site-specific. Each phosphate environmental quality standard is set based upon the elevation above sea level and the alkalinity of the water. Typically they are low, so it could be for good status 0.08 to maybe 0.1 or something like that, and they vary depending upon the specific characteristics. And they're very low and they're hard to achieve because there's a lot of phosphorus everywhere coming from lots of different sources. There's a very good website, and I'll make sure that I send Chris links to all of this stuff, including Coast and Rivers Watch. But there's a website called River Hub that is bringing together lots of different citizen science information, and there, in very broad terms, it gives you some indicative qualities for what you should be expecting for good quality for phosphate in rivers. And I would say if you're higher, you really need to be sort of about 0.1 or lower for good quality. No, particularly after this winter. They get recharged on a regular basis over the winter season, and we monitor the groundwater levels. So we have loggers in boreholes telling us what the amount of recharge is. And if the groundwater levels are very low and there's droughts, then we get very worried. And then we have to start thinking about how we can start saving water. But we're quite lucky in this part of the country where we get a lot of rainfall, and the aquifers are consistently recharged over that winter period. That's not to say that we don't. If you have like a really dry summer, then a dry winter, we would start getting worried. If we get 2 of them in a row, then we get very worried. But thankfully, we've had a lot of rain over the winter, and it is recharging the aquifers as we speak. No, and in Somerset is moving the way of Poole Harbour as well. I think it's going to become increasingly more difficult to put sludge to land going in the future. I was speaking to this gentleman over here who sort of rightly pointed out that microplastics as being a concern, and that is something that we're researching right now. But yes, to bring it back to your point, where it goes, I don't know off the top of my head. I think it depends on where farmers want it really, but the farmers work in conjunction with Natural England and the Environment Agency to sort of regulate the amounts that they're allowed to use, as far as I understand. But yeah, some of it stays within the Wessex area, but I think we do go out as far as the Thames area too. But yeah, some of the trials that we're looking at are sort of focus on the transport of phosphorus out of catchment, which includes sort of slurries and manures as well. And where we are in Somerset, the P indices in the soils is really, really high. And in reality, we probably don't need to put any more slurry or manure on these, and these fields can be utilised for quite a few years before you need to actually start reapplying phosphorus as a fertiliser. But it's a connected issue really. It's like the disposal of manures and slurries is quite often a means of sort of controlling using this resource as a means of sort of disposal. And in some ways, that's the same thing with could be the same thing with sludge as well. Yeah, so legacy phosphorus retained within agricultural fields will be mobilised after a rainfall event, probably in quite low concentrations, but the volume of the water that is coming down the rivers, it does work out to be quite a large load of phosphorus in comparison to the summer. And in the summer, we have sort of higher concentrations but lower flows. So when you sort of assess the load, sometimes it can be actually lower in the summer.
So it's leaching out of the fields?
Yes, it's leaching out of the fields as well. Yeah, and it's how also connected to sort of the agricultural practices as well. We have really huge dairies, dairy industry in this area, and a lot of them, and that poo has to go somewhere. So it's often put onto fields, even though the P indices in these fields is really high already. So I would argue that actually putting it there is not the best place to put it. And there are other locations in England, such as East Anglia, which is heavily agricultural, where they would need those fertilizers more. But sort of the way, yeah, it's such a complicated issue, and it's all to do with, and I'm not here to bash any farmers, because they work in an incredibly hard industry, and there is not a lot of infrastructure to help them to deal with this, and they have to work in a really competitive environment. So when it comes to making a choice between putting your slurry onto that field there or transporting it over into another catchment that needs it, it's going to be cheaper to do it there. So they need to make money. Yes, it's very slow, so you can get build-up of duckweed, but because there's quite elevated concentrations coming from the rivers, and even though the concentrations are reducing and are better than they were a decade ago, they're still too high, and they're still causing eutrophication in those areas, and that is also exacerbated by sort of lower summer flows. So it's hard to, with a lack of water going to those areas too, and also further exacerbated by lots of phosphorus that is retained within the environments, which is further exacerbated by flood events where lots of sediment gets deposited onto these areas in the winter, and it just, yeah, lots of phosphorus coming from everywhere. Yes, yeah, there is. It's gonna be, yeah. There's a lot that comes off from farming and also potentially from sewage treatment works as well, water recycling centres. There's particulates in that can settle down, settle into the river, and then act as a sink of phosphorus. And then if you get an increased flow in the river, these can be distributed and then cause phosphorus to remobilise. Which is also another source. So this legacy issue is a big problem too. I think what you guys are doing now is really important. Collecting those samples and identifying those areas that we need to focus on is really important. Really, the big players in this and the big contributors to the phosphorus issues are water companies and agriculture. I think if you have a home with a septic tank, then I would encourage you to sort of make sure that that's maintained and regularly emptied, and things like that. That really does go a long way, but the citizen science involvement in this is really important. It raises the profile of this, it makes more people aware of what the issue is, and it creates a groundswell of support to actually do something. Some things, yeah. If there's like a real pressing issue that we weren't aware of, then yeah, it would be dealt with straight away. But it's the way that the water industry is funded is on a very slow glacial pace, which is deeply frustrating for for lots of people, myself included. And hopefully things will change now as the Cumlift review has identified a lot of issues and hopefully go from the planning that we have now into something that is a bit more reactive. That would be my hope anyway. I don't really know the answer to that one. I know that we can accommodate growth. We have different types of permits for our assets. Some relate to the size of the work, and some relate to sort of the concentrations of sort of nutrients and other pollutants that go out into the environment. When we increase the size of the works, then these are adjusted accordingly to ensure that we're not putting any additional load. So quite a lot of our works have capacity for additional building. If they don't, then we would get talk to the Environment Agency, say that we need to increase the pass-forward flow to this work to accommodate additional sort of growth within the catchment. But for a lot of places, we can accommodate that. In Poole Harbour, for instance, it's very stringent, and the Environment Agency, I think, can have those controls. This is not my area of expertise, I have to say, but yeah, they do. The trouble is yeah, the Environment Agency really are creaking at the seams and are not very well funded and don't have a lot of capacity to look at this. So a lot of it would be amazing if we could have a lot more farm inspectors out there identifying farms that aren't complying with rules for the farming rules for water. And things like that, because I'm sure there's a lot out there. So there's not really a deterrent So it is a really tricky, it's a really tricky situation. But the way I think that we're trying to deal with it really is by working in partnership with lots of different organisations like like FWAG with the Farming Wildlife Group and Somerset Catchment Partnership and other organisations who are going out and interacting with farmers, trying to give them as much advice that they can, identifying the grants and things that they can utilise to improve their infrastructure and things like that. It's a really tricky one because like farmers aren't villains; they're doing their absolute best, you know, and they're doing a job to try and provide the food that we have. And yeah, it is a tricky one. It's really tricky.